Good morning. How's it going? Are you guys enjoying the show so far? Yep. Good sessions, good speakers. Cool. Who in here was in my session yesterday? Oh, a number of you. Okay. So I don't have to repeat the joke about my name from yesterday, right? That's okay. Let's skip that. Well, thanks again, guys, for being in this session, for being one of my sessions. For those of you that were not in my session yesterday, I'm sorry for you. It was a good session, right? Just kidding. Everything's being recorded. All the content is available online as well. You can see the recording from Ignite. You can see the recording from Tech Summit. It's up to you. So don't panic that you are missing good content. You can review everything online as well. I'm Vinicius Apolinario. I made a joke about my name yesterday. I won't repeat. I usually do, but I won't. I work on the Windows Server team, actually in the marketing organization for the Windows Server stuff that we do. So I'm a technical person inside of the marketing group, so we can have a technical conversation. Actually, that's the idea of this session, to talk about the features inside of Windows Server 2016 for software-defined data center. So think about compute, storage, and networking, and what's new in Windows Server 2016. Those are the things that we are going to cover in this session. I prefer that when we have these kind of sessions, that you guys take advantage of being here, actually, and so you guys are able to ask questions. So if you have any questions while I'm presenting, although I can barely see you guys, just raise your hand, ask the question. We don't have any mics in the room, so I'll repeat the question so everyone can hear the question. Although this is a kind of a smaller room. I'll repeat the questions, and we can have more of a conversation than actually just me presenting and you guys just hearing. I think that's more beneficial for everybody. So let's get started. Like I said, this is the probably the most data center focused session that you'll find in the Tech Summit. The reason why is because we are really focusing on this session on Windows Server 2016 and what we have in Windows Server 2016 for compute, storage, and networking. So what's new in Windows Server 2016? So because I want to have this conversation with you guys, let me start by asking some questions. How many of you guys are already using Windows Server 2016? Okay, good number. How many of you guys are using 2012 or 2012 R2? Oh, that's good. 2008 or 2008 R2? Yeah. 2003? 2000? NT? No one using NT anymore? It's a great story. I come from Brazil, and I was in the Brazil subsidiary of Microsoft, and we got someone from the engineering team visiting one of the largest banks in Brazil, and then the guy said, look, I hear everything that you're saying. It's all great, but you know what? We are still using Windows NT. At that point, the engineering guy that was talking to the customer said, if I was your customer and I knew about that, I would end my account right away. And at that moment, okay, so let's switch gears. Let's talk about something else. We know that you guys have to support old applications or legacy applications. So there's a big investment in Microsoft to make sure that, and this is what we are going to talk about, and that's the reason why I'm talking about this. We are making a big investments on things that we understand you guys are going to take advantage of, right, in the new products. At the same time, we understand that you guys have to maintain what you already have running. So what are the things that we are looking for when we think about software-defined data center? Where we are in the evolution in terms of what's coming, and also what we are bringing from the legacy that we have inside of your companies as well. Because of that, what are the customers that you guys are facing in terms of upgrading, in terms of performance, in terms of cost, flexibility, reliability, and so on? And what are the features inside of the product that will actually help you guys take the next step, right? So this is the main focus of this session. So like I said, let's start looking back, right? So if we look back to the investments that we did and what was the focus of the product at that specific point in time, when we launched Windows Server 2008 R2, along with the System Center components to manage the features in the platform. So think about Windows Server as the platform and System Center as the management piece to manage the platform that we released with Windows Server. So that was the moment in time where we actually introduced virtualization. Let me rephrase that. Server x86 virtualization to the platform, right? Because if you think about virtualization, you probably know that virtualization is a very old technology. It's been out there for decades, but we are talking about hypervisor server x86 virtualization. So basically, we introduced Windows Server 2008, and then we launched an update that introduced Hyper-V to 2008. I don't know how many of you remember that, but Hyper-V was an update for Windows 2008, right? So at that moment, what we wanted was to actually take advantage of virtualization and having virtual machines being able to better use the hardware and start taking some advantages of virtualization, like it's easier to back up, it's easier to deploy, and so on. In 2012, in the Windows Server 2012, we introduced some new features that started to change the virtualization market, right? So we all know that, for example, vMotion is a feature from VMware. They launched this feature. We came up with Live Migration that is the equivalent to vMotion in the VMware space, on the Microsoft space. But in 2012, the Windows Server 2012, we started to introduce some things that VMware was actually starting to catch up to Microsoft. So think about Chernoff and Live Migration. Okay, so vMotion, VMware, but for vMotion and Live Migration to work, you need a shared storage, and then you move the virtual machine between the hosts that you are trying to move, right? Chernoff and Live Migration removes the need for shared storage. And why did we launch something like that? Because we heard from customers. Customers said, look, Live Migration or vMotion are great, but we need to move virtual machine regardless on the shared storage, if they have a shared storage. I have a standalone host, I have another standalone host, and I want to be able to move the virtual machine between the two hosts regardless on the shared storage, right? If we think about this kind of thing, Hyper-V Replica, there are a number of other things that we launched to the product that VMware came up with equivalent on their side as well. So what I'm trying to say here is that for a long period of time, we've been in this battle of catching up on features, right? But if we think about the features that we launched to 2012 and 2012 R2 as well, we were actually looking at the pure infrastructure, right? So what can we do to the infrastructure to support the applications that are running on top of this infrastructure inside of virtual machines, right? Now, things started to change at some point, and that's why in Windows 2012 R2, our design point was actually Azure. Because then when you move to a design point like Azure, you change the perspective and you have to change the way you do the infrastructure to support the virtual machines or the applications. Let me give you an example. If my application can see the fault in the infrastructure, why do I need high availability? Think about it. My application can understand if the infrastructure has a problem. So my application by itself can remediate the application or the infrastructure problem via software. Why do I need a cluster? One of the technologies that is coming out that does something similar to that, you ever heard about microservices, right? Containers, right? Those technologies, they are moving to a level where the infrastructure is actually no longer that important from the application standpoint, right? Now, that doesn't mean that the infrastructure is not important to support the application. It's just that it changes the agility that is needed from the infrastructure for the application to run. And that's the reason why software-defined data center is so important. Software-defined data center, if you think about it, is infrastructure catching up to what development is doing, right? In order to deploy an application, I have to spin up storage, compute, and networking, right? So let's take one of those, networking. How long does it take to reconfigure VLANs in your environment? Is it something easy? Is it something fun? Right? I understand the pain. The developers don't. They don't care, right? The only thing that they know is that when I need to spin up an application, it takes about 2 weeks to deploy the application. What if we could deploy this network configuration via software, and that would take minutes, in some cases hours, but it would take minutes to deploy this network configuration for my application to work. That's the difference from software-defined data center to the old way of doing infrastructure, right? So when you think about 2012, R2, and Hyper-V, a lot of people still think, oh, you know what, I'm sticking to VMware because we've been using VMware. I don't really see the things that you guys are doing. So one of the things that we decided to do is this slide that basically lists the features that we launched between 2012 and 2012 R2. And I don't expect you to read and understand and actually see what each of the features are. I'm just showing you that we've been doing a lot just for Hyper-V, right? We're not talking completely about storage or networking, just for Hyper-V. The things that we are doing to support your applications and make sure that you have the best-in-class hypervisor available to support your virtual machines, right? Now, everything that I'm talking about is this notion that we need to rethink our data centers, right? And the main reason why we need to change this is because if we think about the pressure that exists between the application and the application owners in the development people and the infrastructure, let's think about what is the requirements from the application perspective. They need agility, they need to deliver faster cadences of the updates of the application and so on. And from the IT perspective, by the way, I'm assuming that most of you guys are from the IT side, right? Do we have any developers here? No? Okay, so can I say bad things about developers? No one cares? Okay. So if you think about what are your requirements, you have an SLA. You need to make sure that applications are up and running. You need to make sure that everything is secure. You need to make sure that the performance that the application has is the performance that was agreed with your customers, right? So those are the things that you care about. If we compare the things that application owners and developers want and infrastructure, that's the main reason why IT is seen inside of the company as the blocker, right? Because every time someone tries to create something new, we are the first ones to say, okay, that's not going to work. I have an SLA to maintain. I can't do that, right? So SDDC, Software-Defined Data Center, is the enabler for the IT and infrastructure to change the way we do IT in the data center. We move from the traditional way to a cloud model. Because cloud model is what enables IT to deliver what application owners and developers are looking for, right? So all this introduction is basically to say, look, when we launched Windows Server 2016 along with System Center 2016, those were the things that we had in mind. So if you think about what are the, in Windows Server 2016, what are the 3 things that we tried to achieve by launching Windows Server 2016? First, we wanted Windows Server 2016 to be the most secure OS possible for the application and the hypervisor, right? So the ones of you that were in my session yesterday, you know what I'm talking about. Then we want to make sure that Windows Server 2016, along with System Center, is the best-in-class platform and management for the data center. Of course, we do a lot of things in Azure and OMS, the Operations Management Suite, but for the on-prem side of the house, we have Windows Server 2016 as the best-in-class software-defined data center solution today, right? And then the next step, which is the next session that I have after lunch today, is the application platform, right? Application platform being containers, nano server, how Windows Server can really support the new types of applications that are coming out. Software-defined data center is really in the middle, right? Because software-defined data center provides the 3 components, compute, storage, and networking, that touches security of your data center and also how you're going to move your applications to the next level, right? So this is Windows Server 2016. So again, let's talk about compute, storage, and networking. So let's start with software-defined compute. And when I say software-defined, one of the things you have to remember is everything that I'm going to talk about now, instead of talking about this transition and this kind of communication between infrastructure and application, I'm going to talk about the features that we have in the platform. One of the things that you have to remember while I'm talking about the features itself is everything that we are putting in Windows Server 2016 is actually one of the components of the software-defined data center story that we have for you to support the new applications that you have inside of your environment, right? Now, let's start taking a look on what were the drivers to do compute in Windows Server 2016. So these are the things that we heard from customers in terms of compute. Performance is very important. I need to be able to deliver better performance for my applications, and that means that software needs to talk to hardware in order to deliver that performance that I'm talking about. The other thing is reliability. So I can't have any kind of downtime because of infrastructure transition errors or failures, or because I'm just changing the configuration of the infrastructure. Changing the configuration of the infrastructure shouldn't cause a downtime to the application, right? And the last one is flexibility. So I need to be able to first make sure that the applications that I have are running, and also I need to be able to choose what is the platform that I want to run my application. So one of the things that we did as well was to make sure that no matter the application framework, no matter the operating system that you are running on, we want to make sure it runs great on Hyper-V, right? So these are the features in Windows Server 2016 for compute to address the areas that we are talking about. So from the performance perspective, and we are going to enter in more details on each of these, we have RDMA, high performance live migration. So we are still investing in live migration. We understand that we have a lot of legacy application that still runs on virtual machine, and if you have any kind of planned maintenance, you need to move the virtual machine around and you need to do it faster, right? Virtual machine query, VM load balancing, start ordering a virtual machine, and SMB, investments in SMB as well. All of these are related to performance. So we want to make sure that in terms of performance, as well as scalability, right? We are the best in class. Now, one of the things that you won't see is a comparison, like is Hyper-V faster than VMware, right? You won't see something like that. Why? Because VMware does not allow us to do that. One of the things that is in the VMware products, EULA, their terms and agreements, they don't allow any third party, including Microsoft, of course, to present any kind of research or performance comparison, right? So one of the things that I would like to invite you guys is test Hyper-V. If you are not using Hyper-V today, how many of you are using VMware today? The vast majority, of course. How many of you are using Hyper-V? How many of you are using both Hyper-V and VMware? Okay. For the ones of you that are not using Hyper-V, I really encourage you to test Hyper-V, right? So first of all, Hyper-V is free. You have the Hyper-V server option that you can download. Or if you have any Windows Server license, you can also use Hyper-V. Because we can't prove that we are faster, that we have a better performance, test for yourself. Install ESXi host in your hardware, test the performance, install Hyper-V, test the performance, and take your conclusions. Reliability, and some of the things here are specifically about 2016, only coming from 2012 R2, like for example, Cluster OS rolling upgrade. Great new feature, but it's for 2012 R2. We're going to talk more details. Shielded virtual machines, I won't talk about this one today because we talked about this one yesterday. I encourage you guys to check what this feature is. It's way ahead on whatever other hypervisor you may think about, protection against the rogue administrator or an administrator or a compromised account from your Fabric administrators. Flexibility, we are going to talk about some of the things that are also for storage and compute, but make sense from the compute perspective. So let's take a look at some of the features. Before I do that, one of the things that during the technical previews of Windows Server 2016, a lot of customers asked us is not Microsoft going to extend the numbers in terms of scalability? And the question that I usually come back to customers and ask is, are you really using more than 4 terabytes of memory on the physical server? Are you using more than 320 logical processors? Are your virtual machines using more than 1 terabyte of memory and more than 64 logical processors per virtual machine? And you know what? Some customers sometimes say, yes, I have like one workload that needs more than that. Does anyone in this room needs more than this in Windows Server 2012 R2? Yeah, that's usually the answer. No one is using more than this. But yeah, you know what? There's one customer that came to us and said, look, I need higher numbers. I need to run more than 1 terabyte per VM. I need to run more than 64 virtual processors per virtual machine. And by the way, my hardware is way bigger than that. You guess which customer is that? Azure. Azure is the largest Hyper-V customer. And believe me when I say this, the Hyper-V that they run is exactly the same, right? The proof of that is that we are giving Azure Stack to you guys later in this year. And guess what? That's the same hypervisor. Now, the layer on top of the hypervisor is a little bit different. That's Azure Stack, right? But the hypervisor is exactly the same. And they came to us and said, look, this is not enough. I'm running workloads for machine learning, log analytics. I need more than that. So for Windows Server 2016, we came up with these numbers here. 24 terabytes of physical, for the physical server in terms of memory, 512 logical processors, and like huge virtual machines, 12 terabytes of memory for a virtual machine, and 240 virtual processors per virtual machine. So that's just a proof that if you have any workload that you want to virtualize, in terms of performance, you can get it. Take a look at the Windows Server blog that we did in conjunction with the SQL team, where we are talking about how SQL Server 2016 is taking advantage of these numbers in terms of performance. It's amazing what those guys are doing. So let's take a look at some of the features here. Now, RDMA is probably one of the main things that we did in terms of performance, especially compared to our competitors, right? We are the only one to support RDMA, and the one benefit that we can talk about RDMA is really, think about live migration, for example. The process of doing a live migration is basically looking at the memory, storage, and all the state of the virtual machine and moving that virtual machine from this host to that host, right? Now, in order to do that, you have CPU cycles, right? So you have a performance impact every time you run a vMotion or a live migration, right? When you use RDMA, basically what you do is you offload all that process of the live migration process to the NIC, to the network card, right? So in terms of impact to the performance of the CPU, you see very little impact for that performance because you do that. One of the things that we are going to talk about is storage, hyperconverged storage. When you think about hyperconverged, you absolutely need RDMA because when you start to scale, you need to make sure that the processing needed to have your shared storage between the multiple nodes, you need RDMA in order to offload the process from the processor to the NIC, to the network card, right? That takes us to high-performance live migration. We have some videos available both on YouTube and Channel 9 showing the performance for live migration. I mean, it's crazy what we can do with RDMA for live migration. VMQ is something that we launched for Windows Server 2012. In Windows Server 2012, we introduced a VMQ that basically, when you have multiple virtual machines running in a single host, you need to make sure that they have the correct access to the network card. What we did for Windows Server 2016 is going even further when we created a multi-queue that basically combines VMQ with RSS, and we have also VRSS to the virtual machine as well. So in terms of performance, there's a lot inside of Windows Server 2016. Another thing that we realized is, look, we are, in terms of density, getting to a point where hosts are running more and more virtual machines, and we are running out of capacity inside of those hosts. Now, that's not true for all the hosts that you have inside of your environment. So one of the things that we did was first VM load balancing and start ordering. So they are kind of different, but they complement each other. So the first one is start ordering. And start ordering really is, if I have workloads that depend from each other, like for example, I have a website, but for that website to work, the SQL database needs to be on. For the SQL database to be on, I need my Active Directory as well, right? So I need to start my virtual machines in this exact order in order to have my application up and running. So in Windows Server 2016, we introduced this to the platform, not just to the management layer anymore, right? I need to remember to get out of Skype every time I'm going to present. And VM load balancing does exactly what the name says. So if I have multiple virtual machines running in a single host, and I have another host that still have some capacity available, now Hyper-V can see that and move live migrate the virtual machine between those hosts to move the processing from one host to the other, so I can have equivalent performance in both of the hosts. SMB is basically our protocol for storage, right? So if you think about scale-out file server, basically what we do is we bring the communication to the by using the SMB protocol, right? So one of the things that SMB adds is the capability of using multi-channel. So think about servers with more than one NIC. Instead of using just one single NIC, you can have multi-path for SMB in Windows Server 2016 as well. In terms of reliability, like I mentioned before, one of the things that we are trying to do for Hyper-V is every time you have to change the configuration of a virtual machine or you have any kind of transient failure, we want to make sure that the workload is still up and running, right? So for example, let's say I have a problem with the cluster service inside of one of the nodes in my cluster. Usually that will cause is the virtual machine to fail over from host A to host B, right? So that means the virtual machine is shut down and started in the next host, right? If I have any failure in the host now in Windows Server 2016, the first thing that the cluster will try to do is to keep the virtual machine on and see if the error resolves itself or if there's a transient error like a storage access or network access or something like that. So we won't just turn off the virtual machine. We either save the state or we just keep the virtual machine running, right? So for example, in the case of the cluster service goes out, the virtual machine continues to run, right? Although the virtual machine is running on top of cluster, if the cluster service is not working, the virtual machine continues to work. Another thing is we enable now hot add and remove of memory and network. And of course, this is not something new for you guys that are using VMware, but for Hyper-V, this is something that we add for Windows Server 2016, so we understand that we are, again, catching up on features. So if you have a Windows Server Hyper-V host and you have a virtual machine up and running and you want to change the memory of the virtual machine, usually what you will have to do is turn off the virtual machine, change the memory, and then bring the virtual machine back on. Now you can change the memory of the virtual machine. Now there is one point here, which is the guest OS needs to support that as well, right? So the guest OS needs to be Windows Server 2016 or Windows 10, right? Network does not require that the operating system to be 2016 or Windows 10. It could be 2012 if I'm correct. But you can add additional networks, additional NICs to the virtual machine. This is a great one, especially for customers that are using guest clustering. And guest clustering is one of the things that I think that we are way ahead of our competitors. Guest cluster being, I have virtual machines, and instead of doing the cluster in the infrastructure layer, I do this, or the hypervisor layer, I do this cluster in the virtual machine layer, right? So I have physical hosts, I can have cluster on the physical hosts. I have virtual machines, I have cluster for those virtual machines as well. Now, in order to do that, the virtual machine will also need shared storage, right? How do I enable guest clustering in that case? Well, in Hyper-V, you have a few options. You can use a virtual fiber channel for the virtual machine, so they can talk to your regular fiber channel SAN, fiber channel storage device, and so on. Another option is you can have a shared VHDX, right? The VHDX being the equivalent for the VMDK for those of you who are running VMware. So I have a virtual disk file that is shared between multiple virtual machines, and all of the virtual machines can access the same file at the same time, right? One of the things that we added for Windows Server 2016 based on the response from customers that are using this technology is, I want to be able to resize this file without stopping the virtual machines or the workload that those virtual machines are running, right? And production checkpoints. This is a minor one, but it's very interesting. How many of you guys really use snapshots in production environments? Okay, this is just double checking. You guys know all the effects of checkpoints, right? Snapshots, right? If you don't know what I'm talking about, please stop using checkpoints right away. First of all, checkpoints or snapshots are not backup solutions. You all should know that at this point. But you can cause problems to the application when you restore. By the way, creating a snapshot, there's absolutely no problem in creating a snapshot. The problem is restoring the snapshot, right? When you apply a snapshot to a virtual machine, that virtual machine goes back in time, right? So you can cause problems to the application when you do that, especially applications that are multi-node, like Active Directory, Exchange, and so on, databases and so on. Now, one of the things we did for Windows Server 2016 is production checkpoints. Now, what production checkpoints are the regular snapshots that you guys are familiar with, but when you do that, we start the VSS inside of the guest OS. So that snapshot is basically application aware, right? So the application, when you restore the checkpoint or the snapshot, the application is aware of that, right? So just wanted to make sure that you guys are not creating problems for your environment. For reliability, there are a number of things that we can talk about. First one, and this is the one feature that I really like, not for now, I think this feature in the future will represent a lot. And what ClusterOS rolling upgrades is basically, if you think about every time you have to upgrade to Windows Server, to a new version of Windows Server, there's always this process of upgrading your servers, but especially for a cluster, it's usually a very painful process, right? And the reason is you have this cluster of number of hosts, and if you want to move to a new version of Windows Server, you have to spin up a new cluster. Now, you have a number of options to do that. You can buy new hardware and bring the new hardware to the new cluster, and then start moving the workloads from this cluster to that cluster. Or you can like evict one of the nodes in your cluster if you have enough capacity to do that, and move the workloads to the other nodes, then take this hardware and bring to the new cluster, and then you can do the same thing. But the real problem of this process is you have to spin up a new cluster, right? So ClusterOS rolling upgrade is nothing more than allowing you to bring a new Windows Server 2016 to your existing cluster. So in that case, you have a mixed OS mode cluster. What that means is you have nodes running Windows Server 2012 R2, and that's the requirement. And you have also Windows Server 2016 running on the same cluster. So now you can live migrate or failover workloads between versions of the operating system. You can live migrate a virtual machine from 2012 R2 to 2016 in the same cluster, right? And the approach we took to do that is almost the same as we have for Active Directory. So Active Directory, you have the domain and forest functional level, right? For cluster, you have the cluster functional level now. So what happens is if you have Windows Server 2012 R2 running, you have the 2012 R2 cluster functional level. You can bring 2016 to that functional level. Once you move the workloads around so you can update the hosts, then you can update as well the cluster functional level to Windows Server 2016. So all the other features that we are talking about for cluster are also available for your cluster without stopping the virtual machines or just with a small failover for your other workloads, right? VM resiliency is basically what I was talking about in terms of making sure that if I have a transient failure or if I have a minor failure in the cluster, the virtual machine won't be failed over or won't be stopped because of that. The other thing that we have is the fault domain aware cluster. So historically, if we think about cluster, the cluster for the Microsoft, in the Microsoft story is, I have nodes, and if this node fails, I have other nodes in the same site to support, to fail over that workload, right? With Windows Server 2016, what we're doing is we are bringing the notion of failover to more than nodes. You can establish racks, you can establish sites, you can go further from just nodes, node failover, right? So one example is I have site Chicago and site Seattle for the same cluster, right? And if I have a failure in the Chicago site, I can fail over the workload to Seattle, right? Of course, this is an extreme example. I'm just trying to convey that you can have multiple sites for the same cluster, right? In terms of flexibility, QoS, or storage quality of service, this is something that we are bringing to 2016 as an evolution from 2012 R2. So 2012 R2, we introduced QoS per disk. Now you can apply policies based on workload. You can use System Center to even further have more granularity in terms of how you apply the policy for QoS. For Linux support, we are extending the number of communities and companies that we are working with in order to make sure that those workloads are supported in Hyper-V. And this is a very interesting one. So if you run a Hyper-V environment or a VMware environment, or I would say whatever hypervisor it is, you know that sometimes you need to update the integration tools or the VMware tools that you have inside of the virtual machine, right? So one of the things that we are doing for 2016 is we are making the integration services part of Windows Update. So whenever there's an update available for integration services, it will automatically update itself, right? Of course, it goes through all the process of the WSUS or configuration manager that you have, but this allows you to have the integration services in the guest OS updated to the host, compared to the host, right? So with all of that, one of the demos that I chose to show you today is the VM load balancing. I'm not sure if there's audio in this one, so let's see. Oh, there isn't. So let me just explain what we have here before we get started. What you see here, if you are not familiar with cluster with Microsoft, here you have a cluster called Eldon C. This is Eldon Christensen's environment. You have the roles, virtual machine, and the nodes supporting those roles. And in this case, I have two nodes. One of the nodes is up, running 4 virtual machines, and one of the nodes is down. So all of the processing is running in a single node. What he's going to do is he's going to spin up the second node. So you go ahead and right-click, start cluster service. And what happens here is, if we go to the roles, you see after 1 minute, because that's the time that it takes from the moment that we check the capacity of the nodes, you see that the first virtual machine is being live migrated to the second node, right? Now, after 30 minutes, what will happen is the cluster service will check the capacity of the hosts again, and if necessary, it's going to migrate another virtual machine. What we did was we forced the process, so you don't have to wait 30 minutes, and you can see that the next virtual machine is moved to the second node, so the workload is balanced between the 2 nodes that I have running now, right? In here we forced the 30 minutes, but you actually don't have to do anything. It will automatically live migrate virtual machines around to make sure that the workload is balanced between the multiple nodes that you have in your environment, right? It's one of those things that you see. It's pretty cool, but you actually don't have to do anything, Yes. So the question is, I don't want to have a specific virtual machine or a specific set of virtual machines in these specific nodes. Yes, you can do that. You can create preferred hosts. You can set a virtual machine or a set of virtual machines to evict those nodes. You can balance that as well. And you can turn off the load balancing here, right, if you want. Okay, so with that, let's, no, I wanna move, I don't wanna, yeah. Let's switch gears to software-defined networking. And this is the most interesting one, I believe, in terms of trying to explain the value of software-defined networking. So let's see if we can do that. When we talk about networking, how many of you guys have ever configured a VLAN in a real enterprise-grade environment? I did. Is it a fun process? Yeah. How long does it take to, actually, let me rephrase that. Another interesting thing. Imagine your company today, and imagine that you have to reconfigure all the VLANs. That's not a fun process, right? That will take time. A lot of things to take in consideration. And the reason is everything is tied to the hardware, right? All the configuration that you have to do, you first, some things that most of our customers are saying to us, we have multiple vendors. It's hard to stick to a single vendor. We do when we can, but it's hard to. Even the same vendor, they have different versions of software. So sometimes switch A doesn't talk to, or the management solution for switch A doesn't talk to switch B, right? Reconfiguring all the switches, routers, and so on is painful. And every time that someone's deploy a new application, you have to reconfigure something in the switches or the routers, right? So what happens is that you have multiple layers in your network that you need to configure every time you deploy an application, right? What we are doing with networking is the same that we did for hardware, right? If you think about it, every time you had to deploy an application in the physical server days, you have to spin up a new server, right? What we are doing is we are taking all of the configuration, the hardware topology that you have for networking, and this is some of the challenges that I talked about. So what we are doing is we are combining all the capabilities from your network devices into a single layer that abstracts the physical network to the logical network or the virtualized network. If you think about it, it's exactly the same what we did for servers. A virtual machine sees the hardware as if that hardware belongs to that virtual machine, right? A virtual network will do exactly the same, but instead of a server hardware, is a network hardware or a network device, right? So on top of that, what we do is we are bringing the Azure-inspired software-defined network solution. So this is basically, we're going to talk about name of the features here. So we are bringing the same capabilities that we have in Azure to run in our hosts, in our nodes inside of the Azure Data Center, and we are bringing to Windows Server. So the main component to enable all of this to work is this guy, the network controller. So the network controller is a feature inside of Windows Server 2016 that will oversee the multiple Hyper-V hosts that you have, and you can also integrate with your physical network, right? And because it's integrated with your physical network, and also we own the virtual switch running on Hyper-V, now we can run the virtual network on top of the physical network that you have, right? One of the things that is interesting about this, so aside from the network controller, what we are doing here, this is not new. We already had virtual networks in Windows Server 2012 and 2012 R2 and System Center. The only difference is, well, first, System Center is not a requirement anymore. You can bring System Center and that will help you manage the virtual networks that you have, but you can do everything through PowerShell, and that's the demo that I'm going to show in a minute. But the other thing is, in 2012 and 2012 R2, we were using the NVGRE protocol. That is not a Microsoft protocol, but that is the protocol that we adopted. In 2016, one of the things that we're doing is we are supporting VXLAN as well. So if you are using VMware today, it's a easier transition to the Hyper-V and the Windows Server networking, virtual networking, if you want to do that migration. So how does that work? So when you can abstract the network, the physical layer from the network to the software, what you can do is there are no limits now anymore in terms of blocking an application to be deployed, right? So via software, I can do everything that I'm going to talk about in those slides. So, and then I'm going to show in a demo. So here I have a kind of a 3-tier application. So in this case, we have Active Directory in the back end instead of a database, but you have the web servers, the virtual machines for the web tier. You have file servers here that communicate with the web server, and the file server needs to talk to Active Directory in order to run properly. The first thing I want to do is I want to create the subnets for those tiers that I have, and I have a PowerShell script to do that. On top of that, you want to make sure that those subnets are part of the virtual network. So if you ever deployed a virtual network in Azure, you know that that's exactly what you do in Azure. You create a virtual network, you create the subnets, and you're good to go, right? But what's the point on creating this if you can't talk to the outside world? So one of the things that we have in Windows Server 2016 is a gateway that you can connect the virtual networks to existing networks and the internet. We also added a load balancer. So it's not the regular load balancer that you guys are familiar with from older versions of Windows Server. It's a brand new load balancer, the one that we are using in Azure. You can create ACLs in order to say what is the traffic that is allowed between the tiers and which tiers can communicate with each other. And you put that on, as a virtual network on top of your existing network. So here are some of the things that are new. So the network controllers, the other things that you see are things that were there in Windows Server 2012. And with System Center Virtual Machine Manager, you were able to manage. So we are decoupling the virtual network from System Center. You can use Windows Server only now. And we are also adding some supports for example, VXLAN and so on. So let me show you a demo so you can better understand what I'm trying to say here.
Let's find out what's new in Windows Server 2016 with software-defined networking. Before we get started, let's first understand the problem software-defined networking, or SDN, is solving. Applications are innovating at a rapid pace, and network infrastructure, with its complex set of connections and devices, can't keep up to meet the needs of those applications, all while ensuring constant uptime. Server virtualization solves this problem for servers by placing the application into a virtual machine that is separate from the hardware on which it's running. With SDN, we create a network virtualization layer on top of the physical network so that the requirements of each of your applications are met consistently and independent of the configuration of the physical devices. This makes your applications run more reliably and securely while reducing the churn in your physical network config. Even if you grow your physical network infrastructure, you don't have to worry about breaking the apps that run on top. And your apps can immediately take advantage of new resources. Let's go hands-on to see it in action. We're going to start by creating a virtual network for a 2-tier web application. We'll give this application its own network to keep it isolated from any other applications on the same infrastructure. In this network, we'll create 2 subnets, one for the front-end web servers and one for the back-end file servers. We start by creating a set of objects that represent the virtual network, And within these, we add a virtual subnet for each of our app tiers. We then apply the settings to create the network. And once the network is created, we can attach each of the VMs to it. In this case, we have a helper function to do this, and we call it once for each of the VMs we want to connect. Now let's see the results of one of our web server VMs. ipconfig shows the IP address that we've been assigned, and we can do a ping to see basic connectivity to another web server. We can open up a browser and connect to the default IIS web page on that server to show that, yeah, it's working. In this demo, we created 2 subnets. And since these 2 subnets are part of the same virtual network, the virtual router got added automatically so VMs can communicate across subnet boundaries with no extra effort. This is great for one VM, but what happens as the load on your application grows? Load balancing becomes critical in order to scale out. And so Windows Server 2016 Data Center includes an all-software load balancer for use with SDN. You can use the software load balancer by creating virtual IPs or VIPs on top of your application tiers. These VIPs are the single entry point into the multiple VM instances of an application that make up the tier. And as the needs of the application grow, the number of VM instances can grow as well. The load balancer will continue to make sure the load is distributed evenly. To achieve this, in the next script, I'm selecting a front-end virtual IP for my services, creating a back-end address pool to contain the VMs that will respond to the request to the VIP. And finally, I'm connecting the 2 with some load balancing rules. In this case, I'm saying TCP on port 80 of the VIP will get distributed to the back-end pool members. Let's apply the load balancer configuration. The next step is to add the pool members to serve the requests. I do this once for each of my web server VMs. Applying it only takes a few seconds. Now let's see the result. I placed a uniquely colored page on each of the web server VMs, so depending on which VM serves the page, I get a different color. Of course, if I go to the main page, the app that I've actually deployed, in this case a blog, you can see it's also working. The software load balancer also has the ability to insert internal VIPs within the virtual network for load balancing between the tiers. While it's not required for the file servers in this example, it can be used for other apps that require databases or application gateways. So you know your services don't live in a vacuum. They need to connect to Active Directory, databases, and other services. For that, SDN provides hybrid connectivity to the networks containing other existing services in the same or remote data center. The application owner defines their own gateway configuration that once again uses shared infrastructure to connect to the outside world with minimal involvement from the network admin. Types of gateway connections are as flexible as the needs of the application and include multi-tenant VLAN routing, site-to-site tunneling, GRE tunneling, or any combination of the 3. To show you this in action, for this application, we're going to connect our virtual network to a VLAN with L3 forwarding. Here, we're starting one of the web server VMs. This time, we're trying to go out from the network. I started a ping to show it does not yet have any outbound connectivity. So let's run the script. Okay, the settings have been applied. While we're waiting for the configuration to go into effect, let's take a closer look at the script. The script first retrieves the objects that I'll be connecting. In this case, my virtual network is being connected to a VLAN in the physical network. This VLAN ID, 1002, has been pre-configured in my physical switch by my network administrator. It then creates a virtual gateway service on the virtual network and adds a connection referencing the VLAN subnet from the physical network. It gives the virtual gateway an IP address on the VLAN subnet. Switch back to the VM to watch as the connectivity gets established. Wait for the ping. There you go. Connected. And we can do a trace route to see each hop that it takes on the way out. There's the distributed router, then the virtual gateway, the physical router, and finally the destination. I now have the full ability to send traffic in and out of the virtual network via that VLAN. With this ability to create and connect to your network, the ability to protect it is critical. Cybercrime costs organizations millions of dollars each year. SDN can help here as well. By using the included distributed firewall, you can create micro-segmented boundaries around individual tiers of your application, permitting traffic to only those flows that are required and denying any flow that is not needed for the app to operate. When these rules are applied to the subnets, each VM automatically gets the required rules that are unique to its tier, even if that VM gets added at a later time. Let's add some protection to our web app now. We'll start by defining the rules for our web tier. and then apply those rules to the web tier subnet. That's all it takes. Let's go to the VM. We'll start by flushing DNS to show that DNS lookups are still permitted. Now when we do the ping, we'll get the IP address back for the name, but the ping itself is blocked because we did not allow that in the rules. We'll open up Explorer to check to see the file server access is still permitted, because that's important for the application to run. We'll use the UNC path and connect to it by name. And there you can see we can browse the file share without any issue. We can also open up Internet Explorer to verify that the app itself still runs by connecting into port 80. So you can see each of the web pages still getting served. You aren't limited to Microsoft-only technology. If you've already tooled up by investing in a third party with a virtual appliance that runs on Hyper-V, you can add an instance of that virtual appliance to the virtual network and send traffic to it by taking control of the virtual network's routing table. This is called user-defined routing. Here we're adding a Linux appliance to our virtual network. You'll see the Linux appliance on the right. And you can see it has some background traffic to start because we haven't set up the rules yet. So let's run the script. You can see it's applying this routing table to the virtual network. And within a second, you can see all of the traffic destined for the .2 subnet is now being sent through the Linux virtual appliance for it to inspect and forward as it sees fit. Everything you've seen has been done in real time, done by the application owner without having to take time away from multiple other administrators. And it was done without losing any of the performance you expect from your high-performance hardware. When you're deploying your next app in your existing infrastructure, think about how much easier it could be with the agility of SDN, and go try it with Windows Server Data Center. It's all included in the box.
Okay, two things that I know you guys are thinking. First, I'll allow some questions in a minute. First, how many of you guys really love PowerShell? Yeah, I should have asked, how many of you guys hate PowerShell? Not hate, you don't like PowerShell. Okay, so the question is, I'll never write that PowerShell script. Right? We know that. It's all available on GitHub, right? You can download all the PowerShell, there's all the documentation and the support for you to create your own PowerShell script for your own environment, right? Second one is not a question, but I don't know if you noticed, Windows Server 2016 Data Center. That's important. All the SDN, the networking and storage capabilities I'm going to talk about are only available on Data Center. Now, if you have a virtual environment, you probably already have the data center licensing because you are running multiple virtual machines. For those of you that are running standard, it's important to know that those things that we are talking about, as well as storage, is not available for standard, right? Question?
Yeah, you basically set up a DMZ. Is that correct?
Well, if you...
Traditional sense of the word DMZ.
No, the difference is that network is a virtual network running on top of any physical network. So if you think about DMZ in terms of isolation, that's kind of similar, but the difference is on top of that same network, I can run multiple virtual networks that are isolated from each other, and then through the gateway you can connect all of them, right? But the main difference is you can run multiple networks on top of the same network, and there's another difference. Virtual networks, because they are completely isolated, you can run the same IP address in this virtual network as well as in the other virtual network and in the other virtual network, and they can communicate with the external world. You can't do that in a physical network.
Right. So would that be considered, would that meet DMZ standards as far as security?
Correct, yes. So the question is, will that meet the DMZ requirements or standards? Yes. Yes, it will. Let me just move on to the storage. I have 10 minutes and I still have some things to show you guys. So let me go ahead and start storage. I'll stay here. I have another session. I will be here the entire day to answer questions in case you have more questions. Challenges that customers face, of course, you all want to move faster. So the same way we have for networking, you want to be able to deploy storage for the application, regardless on if I have to add more, regardless on my physical infrastructure for storage. And cost. Cost is probably the main reason why people are looking for storage, software-defined storage. Because let's face it, storage is very expensive, right? Every time I have to deploy a fiber channel device, or every time I have to add more ports in my fiber channel environment, one single port is extremely expensive. So cost is the main one. And of course, flexibility for my application as well. So if we think about what we've been doing with Windows Server, what we did was we added to Windows Server 2012 and 2012 R2 the capability for Windows Server 2016 to be the storage the 2012 and 2012 R2 to be the shared storage device for your Hyper-V or virtual machines or applications, right? The only thing that, if we think about Windows Server 2012 and 2012 R2, was missing is the ability to use its own disks from the server. So in 2012 and 2012 R2, you can have multiple servers as the backend storage in terms of connectivity to your servers, but then you need a shared storage for those servers to access the disks, right? So if you think about a very expensive storage device that you have in your company, you have this black box that is managed by your storage vendor, and there you have disks, and then you have a software that does deduplication, tiering, volumes, and so on. Zoning for your fiber channel environment, or iSCSI as the connectivity for the servers, and so on. Now, basically what we did was we opened the black box and we looked at, you know what, we can take the software out of here and bring to Windows Server. That's what we did. But we still needed the box for the disks. So a JBOD is an excellent solution for storage for Windows Server 2012 and 2012 R2. In 2016, we thought, you know what? Let's remove completely the need for a shared storage from a storage vendor. You can use if you want, but now with Windows Server 2016, you can use the disks inside of the server to be represented as the volume for your application. So what happens here is that when you create a volume in Storage Spaces Direct, which is the name of the feature, you use the disks of the servers and you create a volume on top of all of those disks. So we enable scale-out file server. We have policies for QoS or IOPS per virtual machine, per service, per tenant, and you can manage all of that through VMM or PowerShell. So when we were thinking of how we are going to approach this, we saw two solutions. And the first one was the converged solution, which is close to what we have today, right? The converged solution is you have your application servers, which in that case is Hyper-V host. So my Hyper-V host is running my virtual machines, and it connects to my storage device. The only difference is that in that case, the storage device are multiple servers with internal disks that are represented to the Hyper-V hosts as a single volume, right? As a shared storage. Now, there's another option for customers that are adopting new storage devices today called hyper-converged. Did you guys ever heard about hyper-converged? Yeah, it's one of the trends in the IT today. Hyper-converged is nothing more than bringing together application and storage, right? What I have here is I have, in that case, if you look closely, you have 8 nodes. Two clusters. One, the top cluster is my Hyper-V cluster, and the bottom cluster is the storage cluster, right? Here I have 4 nodes, and I have one cluster with the virtual machines and the storage in the same node, right? Now, what are the pros and cons of each of the scenarios here? The pros of hyperconverged is it's cheaper, it's easier, but doesn't scale very well because the performance of the nodes is impacted by both the performance of the applications, in this case the virtual machines, as well as the storage, right? So up to 12, even in some cases 16 nodes, you can use hyperconverged. If you're running large or high performance applications, you probably need to separate the virtual machines or the applications from the storage layer. So then you want to go to the converged or disaggregated solution, right? The cool thing is Windows Server 2016 Data Center provides both options out of the box, right? If you compare to vSAN, vSAN compares to this side of the house. vSAN only delivers hyper-converged scenarios. And by the way, please test the performance. We use RDMA, and VMware doesn't. So I can't say it, but I would like to. So please test the performance of Storage Spaces Direct in Windows Server 2016. So this should be the last slide, but it's not. So we support any option that you may want to use for storage. So Vinicius, I don't like Storage Spaces Direct. I don't like the hyper-converged idea. I want to use my regular fiber channel device with my regular vendor. Fine, use it. We support that. I want to use a NAS because my applications doesn't require performance. I have everything's running well. I want to use NAS. Go for it. No, I want to use the Microsoft options. You can use with a third-party storage device, or you can use with the internal disks. It's up to you. In terms of partners that are supporting us in this journey, we do have some partners. I recommend you guys to take a look at the Windows Server Software Defined program. Then you can buy hardware and software together along with services. But better than that, let's see it in action, right? So this is a demo for Storage Spaces Direct. What we have here is we have 3 servers with each of the servers have 4 spinning disks and 2 what is the name? NVMe disks or flash devices. So nothing, no shared storage, no fancy cable, just Ethernet, right? What I'll do is I'll open PowerShell. I can do this through the graphical interface. And if you see the disks that I have in each of the servers, so as I mentioned, 6 disks, what I can do here now is I have to form a cluster to be able to all the servers work together. So I'll create a cluster, and that's a simple PowerShell line, new cluster with the name of the nodes that I want to create the cluster. There you go. Of course, there's a warning saying that you need to see the report. And if I look at the nodes in this cluster, I have 3 nodes. Now, what I'll see is I'll take the disks from those nodes and I'll create a pool to be able to make those disks work together and create a volume on top of that. So first thing is I'll enable cluster storage spaces direct. And this command will basically do all the heavy lifting of configuring the disks and checking the configuration from the multiple nodes and so on. There you go. So, oops, I think I missed part of the... Yeah, so now if I look at the pool, I should be able to see all the disks from all the servers, right? So now I have the 6 disks from each of the servers. So now that I have a pool, I can create a volume to support the applications that are going to run on top of this. To create a volume, there's another command. I'll create 5 volumes, if I'm correct here, of 50 gigabytes. There you go. So that's it. We're done. We used 3 servers with six disks each of the servers. We created a pool from those disks inside the cluster, and on top of that pool, I can create as many volumes as I need for my applications, right? Now, one of the things that happens is, what if I bring a new server to this environment? What do I have to do? Nothing. You bring the server, and Storage Spaces Direct will detect that the server is part of the cluster. That cluster has, so let me add the cluster here. I'm sorry, let me add the node to the cluster. Storage Spaces Direct will detect that this is a Spaces Direct cluster, and it will bring the disks of that server to the pool. There you go. The disk is automatically added to that pool. So now it's more space and performance available for my applications to use it. I really need to close Skype. Sorry, guys. Okay. Pretty cool, right?
Do all the disks have to be identical or similar?
That's a good question. Does the disk need to be identical? The answer is no, but we highly recommend that you do add identical disks. And the reason is you lose performance if you don't.
Does it know how to classify what's fast, what's not fast, or delete it?
No, it classifies by itself. So it checks if this is a SSD or NVMe disk or a spinning disk, and then you have the tiers. You have the performance tier and the capacity tier is automatically.
Just two?
2 tiers, yeah.
Is there a service that checks the health of the disk at Liberty?
Yes, that's the cluster service. Yep. I know there are more questions. I'll just move along here. As I still have one more topic to cover before I finish, and that's storage replica. So one of the things that we added to Windows Server 2016 that a lot of customers asked as well is, look, every time I buy a storage device from my storage vendor, I also have to buy an additional device for my other site, and I also have to buy the service to replicate from site A to site B. Now, we just showed you that first, with Storage Spaces Direct, you don't need fancy storage anymore. And in terms of performance, it's great. I really recommend you to take a look at the Windows Server blog where we published some of the information in terms of performance. The next step is, if the cluster can be stretched out to multi-sites, and I don't need a fancy storage device, can I replicate between the multiple sites? Yes, you can with storage replica. It's part of Windows Server 2016 Data Center. It's built into the product, and it works synchronously or asynchronously depending on the latency that you have between the sites, right? So one of the things that they were, are you guys familiar with the Seattle region? Or the region where Microsoft is located. So we have Redmond, where the Microsoft campus is, and we have Belleville, which is another city close to there. I don't know what would be the equivalent here, but anyway, they're like close cities. And one of the things that we did was we created a site of the cluster in Redmond and another site in Belleville, and the latency meets the requirement. So we have synchronous replication between Storage Spaces Direct deployments inside of the cluster inside of Windows Server 2016. You know what that means? That means that every single data that I have in this cluster is replicated automatically between the 2 sites. If I have a virtual machine running, I can fail over the virtual, I can even live migrate the virtual machine, but in other cases, if I have a SQL database inside of the cluster, for example, I could fail over the database without losing any data because the site A is completely gone, right? So this is amazing. Because we ran out of time, I had a video that I was going to show for a storage replica. This video is available online, so I highly recommend that you take a look at it. But guys, a lot of stuff for you to go home and look more for it. I highly recommend that you take a look at the Windows Server blog, where we published how SQL Server can take advantage of this and what is the performance for storage in Windows Server 2016, as well as the networking and the other stuff. I hope you like it. I'll be here for some other questions. Thank you.